All right, welcome back to section 4.2. This is the third of 4 intended videos for this particular section. And this one we're going to be talking about exponential equations. So go down past the graphing to where we have exponential equations. The big deal on this is that we want to get bases alike. Get the bases alike. If we can get bases alike, then we can use the property that I talked about back in the first video of this section, where if bases are alike, then we can logically conclude that the powers must be alike. So that property, I told you we would revisit that property, so this is the video where we'll be doing that. All right, just a couple of comments before we jump right on into example number 4. In order to solve, and we know that solve means to get x alone, we want to get bases alike, but how do we go about doing that? Well, first of all, you're only ever going to use substitution for this. That's the only operation you can use is substitution. You're not going to use adding or subtracting or multiplying or dividing to change your bases. You're only going to use substitution. And the second thing to point out is that 9 times out of 10, you are going to make your bases smaller, not larger. So as I talk about this then, we like the base of 5 because that's as small as I can take it. That's as small as it can get. However, the base of 125 can be rewritten as a smaller base. Right now, it's 125 raised to the first power. But we can rewrite 125 as 5 to some power. So what I'm going to do is I'm going to recopy this entire equation, but the difference is I'm going to substitute 125 with a new number that's 5 raised to some power. All right, so hopefully by now you have figured out that 125 is the same thing as 5 cubed. So notice the whole equation is written exactly the same. The only thing I did was I took out 125 and replaced it with what it was equal to, 5 cubed. All right, remember that rule that says if you use negative powers, you can move your numbers from the top to the bottom or from the bottom to the top. So that's what we're going to use here. We're going to take 5 cubed to the top. And when we do that, that's going to it's going to have a negative power. Well, now I have my bases are alike, so therefore I can say that my powers must be alike, so x is equal to -3. Now, we solved for x, we got it alone, and you can check your work. You can take your calculator out, and you can ask yourself, hey, does 5 to the -3rd power, does it really equal 1 divided by 125? And you'll find that, yes, it does. All right, let's go down to example number 5. Look at our bases now. We have a base of 3 and we have a base of 9. Again, you usually do not make a base larger. Most of the time, you're going to make your base smaller. So let's leave our 3 base alone. We like that. And remember, the only math you're going to do here is to get the same base is substitution. So we need to think about 9 rewritten as 3 raised to some power. Well, 9 is the same thing as 3 squared. So let's rewrite the entire equation exactly as is. The only difference is that the 9 came out and it was replaced with a 3 squared. Now, here's another chance to remind you of a rule that you have seen in the past. And that rule is when you raise a power to a power, then that's going to be the same thing as multiplying your powers together. Notice the bases didn't change. The base stayed the same. The only thing that we did was we multiplied our powers together. So let's implement that rule here on the right side of our equation. We're raising a power to a power, so we're going to multiply our powers together. Don't forget to distribute, so that'll be 2 times an x and 2 times a -3. Well, now we have our bases are alike, so we can say that our powers must be equal to each other. So I'm going to set up a mini equation that says power equals power. X plus 1 power equals 2x minus 6 power. Now all I need to do is solve this little mini equation. So I'm going to subtract x on both sides, and I'm going to add 6 to both sides, and that'll give me an x value of 7. You can plug this in to check your work. So 7 plus 1 is 8. You can ask yourself in your calculator, what is the value of 3 to the 8th power? And then you can look at the other side, and 7 minus 3 is 4. So is 9 to the 4th power the same as 3 to the 8th power? All right, so next, let's take a look here. We want to, it says that we should describe a process for solving exponential equations. And I've already mentioned that we want to get bases alike. And then we also want to solve our mini equation using power equals power, or just using our exponents. All right, so one more example here. The difference is that my power is not where the unknown is. Now my unknown is the base. So let's remind ourselves of that rule that says my fraction powers can be rewritten as roots. So the bottom number becomes the root. We did this in the first video. The bottom number becomes the root, and the top number becomes the power, and that power can either be rewritten inside the root or outside the root. Both are correct. So let's do that first. Let's go ahead and rewrite as, that is not what I did here. I apologize. Okay, so change of plans. This is another way to solve this. I used raising a power to a power. I apologize, I forgot what I had hidden there. So when I raise a power to a power, if I want my power to go away on this side, then I would need to multiply by the reciprocal. So when I raise a power to a power here, notice that my 2's are going to cancel, my 3's are going to cancel, so my x is going to be left alone. And on the other side, I'm raising my 25 to the 3/2 power. Well, here's where I'm going to use this rule that I was a little bit too excited to share with you right off the bat. And so I'm going to have an x equals the square root. So that bottom number is going to be my root. So this is a square root, and I'm going to cube it. And maybe you say, Ms. Roberts, why in the world are you saying that this is plus or minus? And the deal here is that whenever we take the square root of both sides, we need to remember the plus or minus. And even though this does not look like a square root, the fact that that 2 is in the bottom, it is a square root. So we're still taking the square root of both sides. So we need to remember our plus minus, just like we did in earlier chapters when we took the square root of both sides. So the square root of 25 then is going to be 5. And then we're going to cube that number. 5 times 5 times 5 is going to be 125. And again, we will have plus or minus 125. So what you can do is you can take that both a positive 125 and a negative 125 and plug that in for your variable up here to see if it really does give you the number 25 out.